Okay, so here's practice question 6 that was assigned on May 4th. Graffiti highway in wherever covered with dirt so that people will not trespass on the property. Okay. So for the first 10 days, dump trucks bring dirt to the location at the rate of R of T cubic yards per day. That's what the chart is giving us, the rate at which the dump truck is bringing dirt. And then after the first 10 days, dump trucks are going to be replaced by a conveyor belt, which brings the dirt at the rate of C of T is 400 over T minus 9 cubic yards per day. So for the first 10 days, we have this chart with our rates, and the last 4 days, we have our function. So part A, using the data from the table, approximate R prime of 8 and include the units in your answer. Well, if we notice, we don't have time equals 8 on the calendar. That's why, or on the calendar, in the chart. That's why we approximate. And 8 is very nicely halfway between 6 and 10. So we can use those two values and just say R prime of 8 will be approximately equal to R of 10 minus R of 6 over 10 minus 6. So you can leave it at 400 minus 320 over 4, or simplify it to get 20. And now the units, R is measured in cubic yards per day, and T is measured in days. So it's cubic yards per day, or if you want to write it as cubic yards per day squared. Okay, but please make sure you have the correct units. You don't have the right units, you will lose a point. Part B, is there guaranteed to be a value on the interval? Guaranteed, here we go again, such that R prime of K equals 0. Now, if R of T was differentiable, mean value theorem would hold true, it would work. But this question says nothing about R of T being differentiable. So to answer this question, no, there is no value of K on the interval such that R prime of K equals 0, because we don't know the question's differentiable. If we did, this math would be fine. So we have to look for that word differentiable given to us about the values in that chart. If we don't have that word, we can't go to mean value theorem. Okay, part C, the meaning of the integral from 0 to 10 of R of T dt, and then use a right-Riemann sum. Okay, so the integral of R of T dt from 0 to 10 represents the number of cubic yards of dirt. Okay, make sure you are very specific and have the right units. Number of cubic yards, not yards, cubic yards of dirt that dump trucks bring in the first 10 days. And then we want a right Riemann sum. So remember, or right Riemann sum is right rectangular. So our integral is approximately equal to. And we do our base, which is delta x, times the height, and we're using the values on the right. So 2 times 420. Then 5 minus 2 is 3 times 510. Then 6 minus 5 is 1 times 320. And then 10 minus 6 is 4 times 400. And it gives us 4,290 cubic yards. Part D, integral from 10 to 14 of C of T dt. Explain it, then use trapezoidal sum. So our explanation is that integral represents the number of cubic yards of dirt brought in by the conveyor belt from days 10 to 14. Okay, and I do think they would want you to differentiate. This is being brought in by the trucks, this is being brought in by the conveyor belt. And now trapezoid. So trapezoid is 1/2 the height times base 1 plus base 2. Well, we don't have a chart, but we have a function, so I made my own chart. And we're going from 10 to 14, so just, one day at a time. So 1/2, I'm going to use a height of 1 each time, and then base 1 plus base 2. And then 1/2 the height times base 1 plus base 2, 1/2 the height times base 1 plus base 2, and the final one. And this, you don't have to have it in decimal form. You could leave it as the fraction. But if you are using decimals, 3 decimal places. And again, it's cubic yards. Watch your units. Okay. Now we want to know, is the approximation an overestimate or an underestimate? To determine when we have trapezoidal approximation, we know if it's an over or underestimate based on the concavity. And the rules for over or underestimate for a trapezoid are different than tangent line. Just draw, a concave up function and draw in the trapezoid, and we see the trapezoid goes above the function, so it's an overestimate. If we were to do a tangent line, it'd be below, so that'd be an underestimate. So we've done a whole bunch of tangent lines being over or under, but here's trapezoidal. When the function's concave up, trapezoid's overestimate. When it's concave down, trapezoid's underestimate. We could just do a quick review for RRAM and LRAM. Didn't ask us, but RRAM and LRAM are all about increasing and decreasing functions, over and underestimates. So when we have an increasing function, RRAM overestimates, LRAM underestimates. When we have a decreasing function, it's the opposite. LRAM overestimates, RRAM underestimates. So back to this. We need concavity. So we get C prime. There we go. There's our C prime. But concavity is C double prime. Okay? So we take the derivative of that. We get 800 over T minus 9 cubed. No matter where we are in our interval, this is going to be concave up, because we're going from 10 to 14. So this will be a positive value. So C double prime of T is going to be greater than 0. You don't have to draw in the little sketch I just did to help that up a little bit. When we're concave up, a trapezoid is an overestimate. And then the last part, find the exact amount of dirt in the conveyor belt brings to the site. So we have to exactly integrate, which we can. We have the function. We don't even need the calculator to do this one. U sub, if u is t minus 9, du is dt. 400 integral 1 over u du. So 400 ln of absolute value of u. Put our t minus 9 back in with our bounds. Gives us 400 ln of 5, because 14 minus 9 is 5, minus ln of 1, because 10 minus 9 is 1. Ln of 1 is 0. So there's 400 ln of 5, or if you use the calculator, 643.775. Again, 3 decimal places. Okay, so this was a good review of approximation methods. This could be a good question too.